Right, good morning. Today is Friday, May 19th. We're looking at day 4. This is your lesson. So you'll see the two links right here. Just to let you know, we're going to have a guest speaker next Friday, and our test is on Thursday, May 25th. All right, so please make sure you have your day 4 data sheet out. It's lines and curves of best fit. If you don't have this, then please ask the teacher to grab it on the desk and to have one for you. It looks like this. All right, so let's get started. We have when points on a scatter plot seem to follow a pattern, we sometimes draw a line or a curve of best fit to model the relationship. This allows us to make predictions about the relationship. So a line of best fit is a straight line that passes through or as nearly as possible to the points on a scatter plot. So a line of best fit should follow the trend in data. So follow the way of the points. And again, it's a straight line. So follow the trend in data. And it does not always start at the origin. Sometimes it might start like somewhere upwards, but we can see here that like our line of best fit may start like down here and go up. So it doesn't always start at 0, 0. So make sure that you know that. And for a line of best fit, we go through as many points as possible. And we try to get the same number of points above and below this line. All right, so here we have our scatter plot. We're going to draw a line of best fit. So a line of best fit is a line, and it goes through as many points as possible. Again, not always starting at the origin. It doesn't look like we're going to start at the origin here. It looks like we're going to start kind of like here. So it's a straight line going through as many points as possible with the same number of points above and below. Here we can see that we have 1, 2 above, and 2 below. Okay, that looks like a great line of best fit. I'm going to show you not so much a great line of best fit. A not great line of best fit would be something that looks like, I'm going to delete that, like this. This is not in the way of the trend, okay? Or even like this, like maybe you're like, oh, there's the same number of points and above and below it, but it's not in the way of the trend in the data. So also it's not always starting at the origin. Some of them are, but majority of them aren't. So there's our line of best fit. All right, we can see here that it is it strong or weak? This is definitely strong. Is it positive or negative? It's definitely positive. And is it linear or nonlinear? It definitely looks linear. It'd be nonlinear if it was making a curve. All right, so which of the graphs below have a pattern? Let's go look. Okay, and then, oh, here, a curve of best fit, a curve that passes through or as nearly as possible to the points on the scatter plot. But it will be like a curve. So it'd be like something like this, and then you'd have like a curve of best fit. Okay, so which of the graphs below have a pattern? Again, you can pause at any time the video throughout. This is posted on the OneNote. All right, so let's go and see. So go and draw a line of best fit. So it's a line going through as many points as possible with the same number of points above and below. That looks pretty good. It's going upwards. So it definitely has it's more of a weak. See how the points are more spread out farther from the line. It's still positive. And here we can still see that it is linear. And then what about this one? Again, the points are still going in an upwards kind of motion. So again, still weak. still positive. And I'd still say this is linear. And then this one, and it kind of looks like, it could look like a curve. It kind of has like that curve kind of look to it. Could it be linear? Yeah, it still could be linear. More like that. But when it's weak, it kind of like throws it off a little bit, but it still looks linear. Okay, so this is again weak, but instead of positive, this is negative. It's going downwards. And we have again linear. Right, so we do see patterns happening for all of these. As your height increases, your weight is increasing. As your height is increasing, it looks like some people's self-esteem is increasing. We might have some what we call outliers. And then here, this one, as your exam scores go down as you miss more classes. That makes sense. Right, why is the line of best fit not a good model for the data here? Well, for this one, what do we call this? This is no correlation. There's no correlation, so we can't make a model. We can't see anything here. And also, a line of best fit is not good for here because this one's nonlinear. It would be a curve. All right, and a couple of new words that we're looking at here is interpolation. Interpolation starts with in. So this is you're examining data inside the graph. So wherever you plot your points, you're looking at your points inside where the points are. So these are all your given data. And then this one's X. So you're examining, can you guess it? Data outside or exit. The graph. So you're given a whole bunch of data points, but you would have to what we call extrapolate. And this is where you approximate. You're approximating the value. Okay, let's go kind of graph this. So if we looked at something in our first quadrant, and we have like a whole bunch of points here, that looks good. We draw our line of best fit. Well, let's say it's height versus age. So it's height versus age. Let's say your age is 14. So at 14, you would go up, hit the line of best fit, and then go over, and that's approximately how tall you would be at age 14. But let's say this graph only went up to when you are 20, right? And then I'm asking, well, how tall are you going to be at 30, right? So technically you would have to extend the line of best fit, and then is what we call extrapolate. So you would guess. That's how you guess. You guess how tall you are at 30 when you extend the line of best fit. But here at 14, we know how tall we are at 14. This is called interpolate. There was no guessing, right? We had those data points, we plotted them, we see what our height is. But at 30, we're definitely going to have to extend the line of best fit and guess. And then at 30, do you think you're going to be taller, like you're going to grow after 20? No, right? You don't grow after 20. You stay about the same height. So this is an estimation, and this estimation doesn't make sense. It doesn't make sense for you to be double your height from now until 30, unless you have like some crazy growth spurt. So sometimes when you extrapolate, it doesn't make sense. So you really got to watch out for extrapolation. All right. Again, you can pause this video at any time. Please pause the video so that the students like write down their work, and then they have everything written. All right, and then next we are going to draw the scatter plot and line a best fit for the data chart below. Okay, so the first thing we're going to do is we're going to look at the two variables, and here we have time Time is always independent or dependent. Time is always independent. Independent is x. Distance is always dependent, which is y. And anytime we have like a table like that, our x is first and then y. Or a table like this, x is first and then y. All right. So we are going to find what we call the mean data point. In order to find the mean data point, we're going to find the average. In order to find the average, what you do is you add them all up, divide by how many there are. Add all up and divide by number of points. So we're going to add 0 plus 2 plus 3. So to get this mean data point, we're going to do 0 plus 2 plus 3 plus 5 plus 6 plus 7 plus 9 plus 10. Add them all up, divide by 1, 2, 3, 4, 5, 6, 7, 8. There's 8 points. So we're going to divide by 8. And this gives us 42 divided by 8, which is 5.25. We'll do the same thing for the other one, add them all up, and we get 280 divided by 8, which gives us, I'm not going to write that there, sorry. This is 280 divided by 8, which gives us the 0.35. Right, so that's the average of these points. This average is really, really important because our line of best fit is going to go through this point. So this is where our line of best fit will cross through. Okay. So we are going to graph this chart on the next video. So please pause this, make sure students have this written down, and we're going to graph it in the next video.